Arrange the following acid in the increasing order of acid strength. Justify your answer. Hypochlorous acid, chlorous acid, chloric acid, and perchloric acid. Now let us understand the increasing order of this acid strength, and we need to give the reasons for the justification. Acid strength of different oxo acids of same halogen in different oxidation state follows the increasing order. First you will have hypochlorous acid, then comes chlorous acid, then comes chloric acid, then comes perchloric acid. Understand here, acid strength of the oxo acids, the same halogen, increases with increase in oxidation number of halogen. What is the reason behind it? You can say reason. The above increasing order can be explained on the basis of the relative stability of the anion. The anion is nothing but the conjugate base left after removal of proton. For example, if you take HClO n times plus H2O, so here I can say n is equal to 1 to 4 for all the oxo acids, will be in equilibrium with H3O plus ClOn times minus. This is your anion or the conjugate base. Here, greater the number of oxygens atoms in anion of the oxo acid, means its conjugate base, greater will be the dispersal of negative charge through p pi d pi back bonding, and hence greater will be the stability of anion. So let me draw the overall canonical forms of the structure. If you take a HOCl and remove a proton, its conjugate base cannot have more resonance structure. If you take ClO2 minus, you can have greater dispersal of negative charge. Once again, if you have ClO3 minus, can have more dispersal of negative charge, and finally ClO4 minus like this. Therefore, stability of anion means conjugate base, decreases as follows. Therefore, acid strength increases in the above order.